Hi, Mr. Richards here. Today's lesson is on solving inequalities by addition and subtraction. Now, just to refresh ourselves, what is an inequality? Well, an inequality is an open sentence that indicates less than, greater than, less than or equal to, or greater than or equal to. We have two properties here, the addition property of inequalities and the subtraction properties of inequalities. Well, if we first look at the addition property, let's write addition prop of inequalities. Imagine you have three numbers, A, B, and C. Now, the following are going to be true. First, if A is greater than B, then A plus C has to be greater than B plus C. Now, if we come up with a couple of numbers for this, let's say A is, 10. And a number less than 10, or 10 is greater than 5. Let's just say that C is equal to 1. Then I am saying here that 10 plus 1 needs to be greater than 5 plus 1. Actually, I meant to kind of write that in red there, but 5 plus 1. Well, 11 is greater than 6, so that's true. And we're also going to say second thing. If A is less than B, then A plus C is going to be less than B plus C. And if I come up with slightly different numbers here, well, let's say A is 2 and B is 4. And C we'll still say is 1. Well, 2 is less than 4, so 2 plus 1 needs to be less than 4 plus 1. And sure enough, 3 is less than 5, so the inequality stays true. Now, what about less than or equal to, or greater than or equal to? These properties hold true for those as well. So if A is greater than or equal to B, then A plus C is greater than or equal to B plus C. Same thing for the less than or equal to. Now, what about our subtraction props of inequalities? Got to give your props out. If we have A, B, and C, basically once more, if A is greater than B, then A minus C has to be greater than B minus C. And if we use our 10 and 5 again, if 10 is greater than 5, and it is, and let's say C is 1, then 10 minus 1 is going to be greater than 5 minus 1. And of course, 9 is greater than 4, so the inequality still holds true, as it should, with this property. In the second, similar to addition, if A is less than B, then A minus C needs to be less than B minus C. And if we look at our numbers again, if 2 is less than 4 and C equals 1, well, 2 minus 1 needs to be less than 4 minus 1. And of course, 1 is less than 3, And similar to our addition properties, these also hold true for less than or equal to or greater than or equal to. Now we can use these properties as we actually look to solve inequalities. Solve each inequality and check your solution. Well, let's rewrite this so we can actually have it a little bit bigger. C minus 22 is greater than 65. Now, similar to equations, we want to solve for the variable here. We want to get our C alone. And the way we're going to do this is by doing the opposite of the subtraction, which is addition of 22 to both sides. That cancels out, and we're left with C is greater than 87. So one way I can verbalize this answer and actually express my answer is not just C is greater than 87, but to use our brace here and say all numbers greater than 87. And then close our brace. So there in blue is one way of expressing our answer, and we'll go over at least one more as we go through this. Now, we are required here to check our solution. So as we check this, rewrite the original inequality. So C minus 22 is greater than 65. Now, pick a number. We have C is greater than 87. Well, in order to check this, we need to pick a number that is greater than 87, such as 88. So if we put the 88 in, 88, since 88 again is greater than 87, minus 22 needs to be greater than 65. And ta-da, 88 minus 22 is 66, and 66 is greater than 65, so it checks out. All numbers greater than 87, C is greater than 87, is our solution, and it checks out. What about our next inequality? Our key here says we're going to solve by subtracting. So if we rewrite this, we have x plus 23 is less than 14. And sure enough, if we're trying to get this x alone, we need to move this plus 23 over, and we're going to do that by using the opposite operation of addition, which is subtraction. So if we subtract 23 from both sides, on the left side we're left with x is less than, now 14 minus 23 is the same thing as 14 plus a negative 23 if you were to keep change opposite using some of our integer rules. And that solution is simply negative 9. Now in the first example, we wrote out our answer using braces and words. In this example, we can write out a different notation, or slightly different. We're still going to use our brace. But the way we're going to express this now is to say, okay, if our solutions are x's, I'm going to put a little bar here, and similar to an absolute value sign, but just one bar, for x is less than negative 9, and close the brace. Now this is called set builder notation. Now, we are required here to check our solution. So if we rewrite the original inequality, x plus 23 needs to be less than 14, we came up with a solution that all x's are less than negative 9. So, pick a number that's less than negative 9. How about negative 10? If we put our negative 10 in for x, plus 23 needs to be less than 14. Negative 10 plus 23 is 13, is less than 14. And is that true? Sure, 13 is less than 14. So we have found our solution. We have expressed this in what is called set builder notation. We've checked it. It works. We are ready to go. Now, what if we solve this inequality and then graph the solution set on a number line? We have 12n minus 4 is less than or equal to 13n. Well, we need to move all of our variables over to one side. We have a 12n with a minus 4 on the left side and the 13n on the right. Well, this 13n is alone right now, so we might as well move this 12n over there. Right now it's a positive 12n, so we can move that by subtracting 12n from both sides. This cancels. And now don't lose track of this negative. We are left with negative 4 is less than or equal to 13 minus 12 is 1, n, or just n. So we have negative 4 is less than or equal to n. Now, as we go to write this in our set builder notation, we have our brace. We're going to have all numbers n with our bar. Now let's write this with the variable on the left side. So n is something with negative 4. You're not going to simply, for this one, copy this down, since we're moving the variable, or at least writing it on the left side. Notice how this is an opening here? Well, we need to keep the opening facing the n, so n is greater than or equal to negative 4. Since these two inequalities are the same, negative 4 is less than or equal to n, or n is greater than or equal to negative 4, it's the same thing. Now, graphing is an excellent way of actually checking our solution. Because if you're actually thinking, as you graph these, it should be pretty easy to graph. Now, on our number line, I usually put my solution in the middle of the negative 4, and a couple numbers to the right, negative 3, negative 2, negative 1, 0. That's more than you actually need. But then negative 5 and negative 6. And we're going to put a circle on the negative 4. However, we have this line underneath, or equal to. So we're actually going to shade in the circle at negative 4. And now we're going to shade to the left or to the right. Now, a lot of students like to look and say, well, look, it's pointing to the left, so we need to go to the left. Hey, look, it's pointing to the right, so we need to go to the right. Well, I just wrote an answer that includes both, one to the right, one to the left, so what are we doing here? Test your numbers. Look at the negative 5. If you put negative 5 into either of these, really, negative 5 is greater than or equal to negative 4. That's not true, nor is negative 4 less than or equal to negative 5, so it's not the solutions to the left. Let's test the solutions to the right to make sure that those work. Negative 3 is greater than or equal to negative 4? Yes. As is negative 4 less than or equal to negative 3? Yeah, that's true too. So we're going to shade this off to the right direction. And that's our solution. Now, just as a little note here, when you have less than or greater than, we're going to have an open circle on our graph. When you have less than or equal to, greater than or equal to, or even equal to, it's a closed circle. And the reason why, if you were to put negative 4 into this inequality, is it true? Negative 4 greater than or equal to negative 4? Yeah, that's true. So we shade everything that's true, so that's why the circle is shaded. If this was not an or equal to, is negative 4 greater than negative 4? No, it's equal to. Is negative 4 less than negative? No, it's equal to. So you shade in the circle when it's true. Let's continue on. Pam wants to buy season passes to 2 theme parks. If one season pass cost $54.99, and Pam has $100 to spend on both passes, the second pass must cost no more than what? If we think about this in words before we try to write our inequality, basically our two passes, so pass 1 plus pass 2 has to be less than or equal to 100, since she has $100 to spend. Well, if one pass is $54.99, so $54.99, plus pass 2, which we'll just call P, has to be less than or equal to $100. Well, there's our inequality. $54.99 plus whatever the second pass cost has to be less than or equal to $100. Well, how do we solve for P? To get our P alone, subtract $54.99 from both sides. And your result is P is less than or equal to $45.01. So, the second pass must cost no more than $45.01. You could say the second pass must be less than or equal to $45.01 as well. And that is it. And as I record this as we approach Thanksgiving, whether you're listening to this before Thanksgiving or after Thanksgiving or nowhere near Thanksgiving, just take a second to think of something or someone that you're thankful for. And be sure to thank that person, or I guess that thing, as we, at least I, move closer and closer to this holiday. That's it. Good luck.